Dear students, in our previous class, we discussed about qualitative data analysis. In this session, we will discuss about quantitative data analysis. You know that we have two kinds of data, qualitative data or quantitative data. In case of quantitative data, the variables, the qualities or attributes are measured numerically. For example, you want to measure achievement of students. So, it can be measured by achievement test and it will give you the test scores, and these test scores are examples of quantitative data, and this quantitative data are usually comes in ordinal scale, interval scale or ratio scale. Or in brief, I can say, when you are thinking about quantitative data analysis, you should think of the scales of measurement or types of measurement that you are using for your data. You know that there are 4 types of data or 4 types of scales: nominal scale, ordinal scale, interval scale, ratio scales. Understanding the scales of measurement is very important for quantitative data, because when you decide the techniques or statistics for quantitative data analysis, you have to keep in mind what is the scales of measurement or what kind of data you have. So, the details we will discuss in the next session. You know, when I am talking about quantitative data has a lot of advantages, because the number has the powers. Quantitative data helps you go for a statistical data analysis, and once you have a statistical data analysis, your data can be presented by tables, by graphs, and so that your report will be very objective. And there are 2 types of statistics we are using in educational research. So, one is descriptive statistics and another is inferential statistics. And in this session, we will specifically discuss on how descriptive statistics are useful for quantitative data analysis. And in the next session, we will discuss about the inferential statistics. Let me talk about the descriptive statistics. When you have quantitative data, for example, you have test scores, you have personality scores, you have a aptitude test scores. Any kind of number you are having, it may be enrollment, it may be retention, or it may be the number of teachers, or the pupil teacher ratio. Whenever you have a quantitative data, then you think of how this data can be analyzed, how this data can be presented to the readers, so that easily the readers can understand or easily the reader can grasp your findings. So, then you have to think of the descriptive statistic. The first things, once you collect your data, once you enter your data manually or with the help of a statistics software like Excel or SPSS, then you have to think of the measures of central tendency. You have to think of measures of variability. You have to think of the measures of relationships. It all depends upon your research objective, your research variables and your research hypothesis. Let me say about what is this descriptive statistics and why this descriptive statistic is so essential for a researcher. Descriptive name suggests that when you use a descriptive statistic, it will describe quantitatively a group or a variable. So, here if you want to describe the central point of a group or center of the group, then you have to use the measures of central tendency. When you want to describe the divergence of individual scores from the mean or from the center, then you are using measures of variability. When you are interested to see the relationship, the association between variables, then you have to use the measures of relationship or the measures of correlation. So, basically under descriptive statistic, we have to discuss like how measures of central tendency can be useful for a researcher, how measures of variability can be useful for a researcher, and how the measures of relationship helps the researcher. Let me talk about when I say measures of central tendency. You focus on the central tendency. Central means the central point, or it the maybe the main focus of the group, and tendency means what is the, whether it is a high, what is a low, or whether it is a high low or in between. So, then you have to think of a certain particular value, a particular value, numerical value that can explain the entire group, because as you know, central tendency mainly useful when you want to find out a single representative value of an entire group. For example, you have collected data from 200 students about their achievement. Now, you want to describe the students' achievements. So, how can you describe it? How can you describe in a single term? The best way is you have to use a central tendency. The central tendency will give a representative value that summarizes the group performance, which is very useful for a researcher or for a reader. And second point is that the central tendency or measures for central tendency is a very simple statistics. It can be calculated with with or without any kind of calculator or computing devices, and in some cases the central tendency can be identified by simple observation. You see, for example, mode is a central tendency. If you want to calculate the mode by looking by a keen observation, you can say what is the modal, what is the mode, which color or which frequency or which number is mode. Similarly, if you want to calculate the mean, it is very simple. You have to add all the individual scores, then divide by total number of scores, and therefore, the measures for central tendency is very simple, and the commonly used measure of central tendency are mean, median, mode. In education research, using discrete statistics like measures of central tendency is a very essential, because by using measures of central tendency, you can describe the group performance briefly, concisely, so that the reader can understand it. Even you as a researcher, before going for a further analysis, you can also understand what is the tendency of your group, what is the nature of your group. So, that is more important. Now, let us discuss very briefly what is the mean. As I said, mean, or some people say arithmetic mean. So, mean is the one of the most widely used measures of central tendency, because it is so robust, it is so powerful measure of central tendency. It gives more accurate result than other measures of central tendency like median and mode, and therefore, for all our further complicated statistics or higher statistics, we use the mean as a measure of central tendency. Then how this mean will be calculated? What is the mean? It is very simple. The mean can be calculated by just adding all the observation, all the values, all the scores divided by total number of individual or total number of sample. And but mean has some of the key characteristics, like mean is always stable, mean is therefore is robust, mean is therefore is a very useful for higher order statistics, but it has certain limitations. When in your data there are outliers, outliers means they are the extreme scores, they may be very high scores or there may be some low scores. These are called extreme scores or outliers, but in your group when you have outliers or extreme scores, then mean may give inaccurate results, and therefore, we prefer that not to use mean when we have outliers and when we have extreme scores. Otherwise, mean is the most suitable measures of central tendency. And the next measures of central tendency that is useful is the median. So, median is another measures of central tendency which gives the middle value of a distribution of a scores arranged in a particular fashion. So, median will be useful when you have outliers, when you have extreme scores, then you can use the median. And the second point also, you can use median when you are using a scale, not the test scores. You are using a rating scale. When your data is in ordinal scale, so you cannot use like interval for interval scale you cannot use the median, because for interval and ratio scale your mean is most appropriate, but when your data is in ordinal scale you can go for a median. So, when mean is not useful, like when outliers are there, extreme scores are there, so then you can use median as a measures of central tendency. And the last measures of central tendency is mode. Mode is very simple. Mode is the score or that comes most frequently in a group. Suppose you have 100 individuals and 100 scores, and you find that one particular score, suppose you say 45, is repeatedly coming, then we can say this 45 is the modal score. So, therefore, the mode can be identified by simple observation, but some of the times we have more than one mode. When in a distribution on a set of score you have only one mode, then you say that is a unimodal distribution, but in some cases you have two modes, two scores that is repeatedly coming, then you have a bimodal distribution, but in some cases there are many modes are there, then you say that is a multimodal distribution. And mode is particularly useful for categorical data or for nominal data. In case of nominal data, suppose you want to find out what is the dress pattern of the students today, then the best way is you go for a mode, identify the most used or most weird dress patterns. So, therefore, mode is a measures of central tendency we have to use when we have a categorical data. So, these are the three different types of measures of central tendency: mean, median, mode. Again I am telling, median is useful when your data is measured in terms of a ordinal scale. When your data is in nominal scale, then you have to go for like a mode, but when your data is in like a interval scale or ratio scale, so you have to go for a like a mean as a measures of central tendency. But the measure of central tendency, whatever you are using, it definitely will help you to understand the nature of the group. Understand your group will help you to express or to report the group performance very briefly, so that others can understand it. But next discrete statistic is measures of variability or measures of dispersion. So, if you focus on the term variability, so variability means this is a spread, dispersion means it is also spread. Variability refers to the spread, the dispersion or the scatter of data. You have a group of scores, and every group of score you have a central tendency or you have a mean. But this variability will try to explain how each and every individual are scattered or spread from the center, because this is very useful to understand the nature of the group. The nature of the group means sometimes we say this group is heterogeneous. Heterogeneous means the spread or the variability is more here. You say the group is homogeneous, that means spread is less. Therefore, here the variability is less, and in case of variability or dispersion, most of the times we use mean at the central point to calculate the variability or the dispersion, and therefore, we can say that the mean is the authentic statistics, mean is the robust statistics, because it is useful for all higher order statistical calculation. Measures of central tendency also complements the value that you calculated from central tendency, because by using mean you calculated the mean of a particular group. Only mean of the particular group express something about the nature of the group, but if you understand the all nature of the group, if you understand fully the nature of the group, then you have to go for variability. So, that means mean and variability both can help a researcher to understand the nature of the group, because depending on the nature of the group, then the statistical techniques will be decided. And when I say measures of variability, it is also useful for seeing consistency and reliability of your data. When you are collecting data or you are studying a particular group or a group of data, set of data, you have to use a variability to see that whether your data is reliable, I mean whether your data is consistent. And we have different types of variability. There are different types of variability are there. We can have a range. Range is a kind of variability that is very common. Range means the difference between the highest score and the lowest score is the range. And we can have a quartile deviation. Here in case of quartile deviation, we have 3 quartile deviation: quartile 1 25%, quartile 2 50% or median, or quartile 3 like 75%. So, quartile deviation also explains how the group is divided, how the group is spread in different quarters. And we can also have a standard deviation as a measure of variability. One of the most robust and standard variability is standard deviation. So, standard deviation is the most robust variability. Therefore, it is used for all higher order statistics. When you study the t test, f test, you will find the use of mean and standard deviation, because these are very robust. And therefore, let me say about the standard deviation. The standard deviation is the most commonly used measures of central variability, and because it provides a clear understanding of a data and how it is diverse from the mean, or how it is vary from the central point or the mean, because measures of variability. Central tendency is came from, or it is derived from the variance. The variance is the difference between the individual score minus the mean and the square root. So, therefore, the variance is very important to understand the standard deviation. So, the square root of the variance is known as the standard deviation, and therefore, standard deviation is square root of variance, derivative of variance. And standard deviation useful in normal probability curve, because in normal probability curve it is divided into 3 standard deviations, right side I think positive side, and 3 standard deviation in the left sides. And therefore, standard deviation is widely used in all other statistics. The basic use of standard deviation here is that it indicates whether your group is homogeneous or whether your group is heterogeneous, and this is very important for a researcher to go for a further data analysis. And there is another descriptive statistics is the measures of relationships. because measures of relationship, if you see or if you focus on relationship means the association between two variables or more than two variables is there, but here we will focus on only two variables, and that is known as bivariate situation. So, if you want to study the relationship between achievement and socioeconomic status, achievement or mental ability, so you are interested to find out the relationship, and this relationship is a linear relationship. This relationship is bivariate relationship, because it is only two variables. So, relationship, measures of relationship can be studied by calculating or by using correlation. So, correlation is a statistics, and which gives correlation coefficient, which indicates the degree of relationship, which indicates the degree of association between two variables. So, the correlationship can be positive correlationship or it can be negative correlationship. The correlation value is always limited to -1 to +1. -1 perfect negative correlation, +1 perfect positive correlation. In between we have a many different levels of correlation. But one important point I would like to tell about here, the correlation indicates only the relationship between two variables. It does not indicate the cause and effect relationship. Like if both variable like achievement and mental ability are positively correlated, I cannot say that mental ability is a cause for achievement. That kind of interpretation statement the researcher cannot make. Researcher only say that the mental ability and achievement is only related. That is the limitation of the correlation. Correlation only indicate the relationship, does not indicate the causal association. And as I was talking just about, there are different types of correlation. The correlation can be positive correlation, when one variable increases, another variable increases. For example, when achievement is increasing, the mental ability also increasing. So, that is a case of positive correlation. But in case of negative correlation, when one variable increases, other variable decreases. For example, when study habits decreases, then study habits decreases and another variable like achievement, suppose achievement is increasing. So, then here say negative correlation. Negative correlation, one variable increases, another variable decreases. For example, one student reduce the reading time, decrease the reading time, then student achievement, suppose say it is increasing, study hours decreased, student achievement increased. So, this is a case of negative correlation. And we also have zero correlation, when one variable increases, another variable decreases, one variable decreases, another variable increases. When what happens, there is no specific pattern of relationship between one variable with the other variable, then there is a zero correlation. So, when you are doing correlation data analysis, it all depends upon your variable, or it all depends upon research objective. If in your research objective is that to find out the correlation or to find out the relationship between two variables, then we have to go for a correlation data analysis. So, after calculating correlation, then you can determine whether it is a positive correlation or it is a negative correlation or the zero correlation. When your calculated value, which we say correlation coefficient, is coming as a minus, suppose you say minus 0.47, it indicates that it is a negative correlation. When your calculated value is coming 0.78, so that is a positive correlation. So, we can have a positive, we can have a negative correlation. this all can be determined after calculation. Then correlation can be calculated by using different formula, different methods. Basically there are two ways or two method to calculate the correlation, and again it depends upon the kinds of data you are having. When you have a rank data, or when you have a order data, or when your data is in ordinal scale. So, you have to use a rank difference method, that say the Spearman rank correlation coefficient. So, we have to use the rank difference method to calculate correlation when your data is ordinal scale. But when your data is interval scale, when your data is like a ratio scale, then you can go for a Pearson correlation or Pearson product moment correlation. So, calculation of correlation is a little lengthy process. You can calculate it by manually, or you can calculate by using any computer statistics or computer software you can use, and you can calculate it. So, dear students, in this session we have discussed very briefly the descriptive statistics and how it is useful for quantitative data analysis. And we started our discussion with the measures of central tendency, then measures of dispersion, and finally the measures of relationship. And these three measures are useful to understand the nature of the data, are very useful to understand the nature of the group, because these statistics, especially the central tendency and mean and the measures for dispersion and standard deviation, is very useful for higher order statistics. And finally, the correlation may be positive, may be negative, it can be ranked or it can be product moment correlation, but its use depends on the kind of variable you are having, the kinds of objective you are having. If you have a objective to find out the relationship association between two variables, then you have to use correlation as a statistical methods. And all these discrete statistics, correlation statistics, these are all useful for describing your variable, describing your groups. You can present the statistical value either in a table form or a graphical form, and then you can interpret it. But only one point I want to tell you that by using discrete statistic, you cannot go for a inference, you cannot go for a generalization. These discrete statistics are only to describe what is the mean, what is the standard deviation, what is the correlation. Only you can describe the group, only description you can give, but you cannot go for a inference, you cannot go for a hypothetic testing. For this you have to understand or you have to apply the inferential statistics. So, in the next session we will discuss on the inferential statistics and how it is useful for quantitative data analysis.